Okay, we're on problem number 80, and again, look like there's some work to do here. And let's write this down. And what do I see? X squared minus 4x plus 3. Now again, there are things I could do with the bottom, but right now I'm not worried about the bottom too much. It's the top that I'm worried about. I'll write this one down for you. X squared, let's see, minus 4x, and then plus 3. And then I see 3x squared plus 3. And then I see minus the quantity x cubed plus 3x times the quantity 2x minus 4. I'm kind of looking at that, and I don't see much in common factor-wise between the two terms, right? Now, I'm saying the two terms, I'm looking at this term over here, a long, complicated term, by the way, that term there. I don't see any common factors. So really what am I left to do? I'm left to kind of multiply it out and hope for a lot of terms to come together. Before I do that, though, I want to relax a little bit and look at the bottom. And the bottom does look factorable, by the way. And looking at it, I mean, x squared minus 4x plus 3 is simply just, x minus 3, x minus 1. I know I have to square that, but let me just make sure I got this part right. It's x squared. You do get minus 1 minus 3, which is minus 4, and you get plus 3. But they are being squared. Put this over here. Now, granted, that might be wishful thinking, but I do like to, write that down in factored form, by the way. And it's important when you get to calculus that you try to factor as much as possible. Let's go to the top. Far more complicated, by the way. I'm going to delay the inevitable. And what I'm going to do, I'm going to distribute the x squared now across those two terms. And what do you get? Well, you're going to get 3x4 plus 3x squared. Right, that's done. Now I'm going to move on to this, which is minus 4x, and I'll distribute across those two terms. What do I get? Minus 12x cubed minus 12x. All right, I'm going to keep moving on. I'm going to do this guy now. So what are you going to get? 9x squared plus 9. That's done. All right, so I'm going to say we just did this. We just did it. We got this done. Let's do the next guy. Minus. Well, multiplying. It's, binomial times a binomial. One term at a time, by the way. What do you get? 2x4 minus 4x cubed plus 6x squared minus 12x. Now, certainly I'm going to try to chase one rabbit at a time, and the first rabbit I want to chase is the 4th degree. I'm seeing that here, and I'm seeing that here. And I want to write that down for you. We'll put the bottom down first. Don't want to lose sight of that. And what do we get? 4 minus 2, which is just 1. So I can put x4 down. Now, I got to be honest with you, this can be very frustrating for students who are doing this thing and they're making mistakes and looking at the key and saying, I'll never get their answer, right? Mistakes happen. You want to prevent that from occurring, right? The next thing I want to go to is I'm going to go to the cubic terms. I'm going to look around for those, and I see that right there, all right? So what do I see over there? Well, minus 12 minus a minus 4, which can be minus 8. X cubed. I'm going to clip that off, say that's done. All right, I'm going to go on to the square term now. See one here. I see one here. I see one here. I want to combine them together for you. So, I see 3. I see 9. That's 12. And then I see minus 6. And 12 minus 6 is 6. All right, I'm kind of looking at this, and there's really not much remaining here. I'm not going to highlight them now, but I'm seeing the minus 12x minus a minus 12x, so there's no x's, and then I see a 9. All right, I don't see much to do with this problem over here at this point. Let me erase this over here. Over enthusiastic about the length of that fraction. If I can put a box in this over here, we'll look at the key later, by the way. But I do want to write the restrictions down. And I'm glad I factored it, because I can see this now. I mean, we got this thing already factored out, I just did it, and it's right over here in the final answer. So x can't be 3, and x can't be what other number? It can't be 1. All right, let's get our red pen out and see if we got the answer. And this is problem number 80. So I'm seeing the x minus 3 squared in the bottom. I'm seeing x minus 1 squared in the bottom. I'm seeing x4. I'm seeing minus 8x cubed, plus 6x squared, plus 9. But again, I'm also seeing that restriction. You can't let the x be 3 or 1 for this to remain to be equivalent. Thank you.